Hello students, welcome back to my channel. How are you doing? I hope you are doing fine. Okay. Now we have been discussing questions which were asked on the 1st of February 2023 JEE mains. So in continuation with the other questions, the question 17 we have already discussed. You can kindly check the other videos, okay, in the playlist. Right. So question number 18, the average kinetic energy of a gas molecule is proportional to absolute temperature, dependent on nature of gas, proportion to pressure, proportion to volume. Now here, if we can write the average kinetic energy of a gas molecule, it is basically per degree of freedom it is kT by 2. And if F is the degrees of freedom, it is FkT by 2, where K is the Boltzmann constant. Boltzmann constant is nothing but universal gas constant divided by Avogadro's number. So based on this, we can see that the average kinetic energy will depend both on the degrees of freedom, which will depend on the nature of the gas, of course, as well as the temperature. So here both the options are given. Okay. So we don't have correct option. Maybe students, I have picked these questions from different sites, different online sites, and most of the online sites they claim that the answers are memory based. I mean, the questions are memory based. So maybe what I feel is that they are asking average translatory kinetic energy. Translatory kinetic energy. If that be the case, then you have to consider only the degrees of freedom corresponding to translatory motion, which is 3 in all the cases, regardless of the nature of the gas. Whether it is monoatomic, diatomic, polyatomic, non-linear, linear, whatever it is, ODF, F will be 3. So in that case, average kinetic energy will be 3 kT by 2, and we can say that it depends only on the temperature. So most probably the question asked is the average translatory kinetic energy. So A option will be the correct answer. Then moving to the next question. A mercury drop of radius 10 power minus 3 meter is broken into 125 equal sized droplets. Surface tension of mercury is this. Gain is surface energy. Now students, what happens is whenever a bigger drop disintegrates into smaller droplets, there is certainly an increase in the area, and whenever area increases, the surface energy will increase, because all the molecules which reside on the surface of a liquid, they possess additional energy in comparison to the molecules which are well within the liquid. So that means the moment the area increases, more molecules have to come onto the surface, and they should possess additional energy as compared to other molecules which lie inside the liquid. So naturally there is a gain in energy, gain in surface energy. Now the additional energy possessed by all the molecules lying on the surface per unit area is equal to surface tension. So the required additional energy will be simply the increase in area multiplied by surface tension, because for every unit area, the additional energy will be equal to T. So for delta A area, it will be T into delta A. Now suppose if R is capital R is the original radius, and small r is the radius of each droplet from small droplet. Then the original area is 4 pi r square. If n is the number of droplets to which it has split, so we can write n times of 4 pi small r square is the new area. So this is the initial surface area, and this is the final surface area. So change in area will be final surface area minus initial surface area. So final surface area is 4 pi into n into small r square minus capital R square here. I have taken 4 pi common, students, like this. Now capital R is already given as what? 1 millimeter. Capital R is already given. So we just have to find small r. N is also given as 125. So not a problem. Surface tension is also given. So we have to express small r in terms of capital R. That can be obtained. We can apply the law of conservation of volume or mass. Density remains constant anyway, so we can equate the volumes. So the initial volume of the single drop was this, whereas the final volume of all the droplets put together is this. So from here we can see r cube is equal to n times of small r cube capital N goes below this, so we have small r is equal to capital R upon n to the power 1 by 3. So let us substitute here. We have 4 pi into r square into cube root of n minus 1 into t. After simplification, you get this. So substituting the values, you get the answer. So 4 into 3.14, radius is 10 to the power minus 6, was minus 3 whole square. Cube root of 125 is 5, so 5 minus 1 is 4, and surface tension is 0.45. 0.45 can be written as 9 by 20, because 0.45 is 0.9 by 2, 0.9 is 9 by 10. Now we have 2 tens are 2 twos are. So here we have 2 nines are 18, so 4 3 are 12.14 into 18 into 10 to the power minus 7. You can see all the options are in 10 power minus 5. So what we are supposed to do is, we can shift one decimal to the left here. We have 1.214 here, and here 1.8 into 10 to the power minus 5 joule. So this is 12, 1.2 into 1.8. So 1.8 multiplied by 1.2 is slightly more than 1.8. That will be somewhere around 2.26. So into 10 power minus 5. D option is the correct option. Moving to the next question. 1 mole of gas at temperature T is adiabatically expanded to double its volume. The work done by the gas in the process. Now students, we can see that we'll apply first law of thermodynamics to calculate the work done. As you can see, in case of adiabatic process, Q is 0. Q is 0. So W is actually minus delta E. For any process, delta E is always equal to NCV delta T. So I can write here as CV delta T is final temperature minus initial temperature. Okay, so N is 1. CV is FR by 2 into T minus T dash. I have absorbed the minus sign here. So it's a matter of substituting F and T dash. Let us calculate it. We can see gamma is given. So based on that, we know that gamma is 1 plus 2 by F. So if you substitute gamma as 3 by 2, then after simplification, you get F is equal to 4. So that is what we got. Now coming to T dash, we can calculate T dash if we apply the formula for adiabatic process. Here you can see we have been informed that the volume gets doubled and we have to find the temperature. So let us use the formula. TB power gamma minus 1 is constant. As you know, for an adiabatic process, the relationship between temperature and volume is this. So I can write the new temperature is T dash, new volume is double the initial volume, initial temperature is T and volume is P. You can see the gas gets doubled, it's given. So we have gamma as 3 by 2, gamma is given as 3 by 2, so 3 by 2 minus 1 is half. So this will be 2 to the power half. So the new temperature is T by root 2. So let us substitute here. So F is 4 into R by 2 into T minus T by root 2. So 2 2s are 4. If you take this 2 inside, you will have R, T can be taken common. We have 2 minus root 2. RT into 2 minus root 2. The option is the correct option. Moving on to the next question. For 3 low density gases A, B, C, pressure versus temperature graphs are plotted while keeping them at constant volume as shown in the figure. The temperature corresponding to the point K is. Now notice the word low density, students. When a gas has low density, it behaves more like an ideal gas, or its behavior is more closer to an ideal gas. So we have to treat it as an ideal gas. For an ideal gas, the relationship between pressure and temperature is this: PV equal to nRT. So using the formula PV equal to nRT for an ideal gas, you can see P is proportional to P, where P is absolute temperature, that is temperature in Kelvin scale. Kelvin scale. Now notice students that corresponding to this point, the pressure is 0. If you put pressure at 0, temperature has to be 0, but 0 Kelvin. So this point must correspond to 0 Kelvin. So 0 Kelvin is not there, minus 273 degrees Celsius is there, which is same as 0 Kelvin. Then coming to next question, the Young's modulus of a steel wire of length 6 meter and cross section area this much is this one. The wire is suspended from its support on a given planet. Block of mass 4 kg is attached to the free end of the wire. The axis into gravity on the planet is this. This is a simple formula based question, students. Just draw a simple diagram. Okay. Let us say that the length is L and increase in length is small l. The restoring force will be equal to the weight. Remember, restoring force will balance the weight. Cross section area is A and Young's modulus is Y. Okay. Then the basic formula states stress is equal to Y into strain. Now students, around 85 to 90% of the questions related to elasticity, they revolve around this simple formula. Okay? Because most of the problems which are asked from elasticity, they make use of, they require this question, this formula. So stress is force upon area and strain is increase in length upon horizontal length. And this force is nothing but mg. So just it's a matter of substituting the values, that's all. So mass is given as how much? And I'll solve here. Mass is given as 4 kg. So 4 into axis due to gravity is 1/4 that of the, on the earth it is 10, so it is 1/4 of 10. Into area. Area is 3 millimeter square. We have to convert this into meter square. So 10 power minus 6. Milli is 10 power minus 3. Square it becomes 10 power minus 6. Young's modulus is given as 2 into 10 power 11. So 2 into 10 to the power 11. Change in length we have to find. The original length is given as 6 meter. So this should give you the answer in meter. Okay. The options are in centimeter and meter. That will take care of that later. So here you see 3 2s are and this 2 gets cancelled. So we are left with here 10. This 10 power minus 6 goes up, becomes 10 power plus 6 is equal to 10 power 11 into small l. So small l is 10 power 7 upon 10 power 11, that is 10 to the power minus 4 meter. Okay. So the options can be in millimeter or centimeter. So this will be 10 power minus 1 into 10 power minus 3 meter. 10 power minus 1 is 0.1 and this is millimeter. So correct option is D option is the correct answer. Moving to the next question. A Carnot engine operating between two reservoirs has efficiency 1/3. When the temperature of cold reservoir is raised by X, its efficiency decreases to 1/6. The value of X and the temperature of hot reservoir is 99 degrees Celsius. Now needless to say, students, we have to convert everything in Kelvin. Okay. So 100 degrees Celsius will be 373. So minus 1. So 272 Kelvin. Now this is the temperature of the reservoir, that is source. Now since it's a Carnot engine, we can write efficiency, formula for efficiency is 1 minus T2 by T1, where T2 is the temperature of the sink and T1 is the temperature of the source. So initially it is given as efficiency is 1/3. So 1/3 is equal to 1 minus T2 by 371. So sorry, 372. Or we'll keep it as T1. Later we'll substitute it. So therefore I can write T2 by T1 as 1 minus 1/3 is 2/3. Then the new efficiency is 1/6. So 1/6 is equal to 1 minus T2 plus X. Temperature of the sink has been, cold reservoir means sink has been raised to this. So therefore I can write T2 plus X upon T1 is 5/6. So therefore from equation 1 I can write T2 as 2 T1 by 3, and from equation 2 I can write T2 plus x as 5 plus x T1. Okay. So if we take the difference, we get x. So x is basically T1 into 5 by 6 minus 2 by 3. Now let us substitute T1 as 372 Kelvin. So we have 372 Kelvin into, if you take LCM, LCM will be 6, and here 5 minus 1 by 6. So 6 is 36, 6 to the 12. 62 Kelvin is the answer. Then coming to next question, question number 24. A certain pressure P is applied to 1 liter of water and 2 liters of liquid separately. Water gets compressed to 0.1%, whereas the liquid gets compressed to 0.03%. The ratio of bulk moles of water to that of liquid is. Now let us understand what is given. Water is compressed by this, and the liquid gets compressed by this. So what is the meaning of this? Now suppose you have some liquid, let us say water or anything. So this is the original volume. When a pressure is applied, let us say that this much part of the liquid gets compressed. So change is dV. So decrease in this will be minus dV. So therefore minus dV by V is the fractional decrease in volume or fractional change in volume. Fractional change in volume. When you multiply this by 100, you get this or this. Okay. So this percentage is basically the percentage decrease in volume. For water it should be 0.01 student, 0.01%, and for the liquid it is 0.03. And take this as 0.01. Okay. Then we have to find the ratio of Bulk's modulus. So we have to find the ratio. Now Bulk's modulus is given by minus change in pressure upon volume strain. This is the formula for Bulk's modulus. As you can see, equal pressure is applied to both. So this remains constant. This remains constant. So we can write K varies inversely as the volume strain, and you can very well multiply by 100, not a problem. Okay. If you multiply or divide an expression, the proportionality sign will not change. So basically we have to get the inverse ratio of this. So K for water upon K for the liquid is the volume strain for the liquid in percentage, no problem, upon this. So basically it is 3 by 1. So X is 1. Okay. X is 1. And if you take it as 0.1 itself, then you will get some other answer. Then probably you will get 10. Okay. If you take this as, instead of 0.01, if you take this as 0.1, so this will be 3 by 100 into 1 by 10. So 3 by 10. So maybe X is 10. If you take this as 0.1, then X will be 10. Alright students, moving to the next question. The surface of water in a water tank of cross-section area this much on the top of a house is h meters above the tap level. The speed of water coming out through the tap of cross-section area this much is this much. At that instant, dH by dt is minus x into the value of x. Now, let us say that this is the overhead tank and this is the water level. Okay, that is connected to a tap here. That is connected to a tap like this. Now the level difference between this is h. From here till here it is h. It is given. Now minus dH by dt, I take minus to this side. So basically minus dH by dt is the rate at which this level is falling. This is fixed level, but this is decreasing as water comes. So basically it is the velocity of this surface. So basically it is velocity of this surface V. Area is given as 750 centimeters square. I take this as A1 cross section area is 750 centimeters square. Now coming to this tab, the area I take it as A2, which is given as 500 millimeters square, and also the velocity V2 is given as 30 centimeters per second. Okay, 30 centimeters per second. This is what is given. So now it's very simple, student. You can see we can apply the equation of continuity. If we apply the equation of continuity, we'll have A1 V1 equal to A2 V2. So we'll get V1. So applying the equation of continuity, we can write A1 V1 is equal to A2 V2. So A1 is how much? 750 centimeter square can be written as into 100 millimeter square, because we have to cancel the units. Into V1 we have to find A2 is how much? A2 is 500 centimeter square, 500 millimeter square, and V1 is 30 centimeters per second, because we have to calculate answer in meter per second. So centimeter should be converted into meter. Let us cancel 252s are 253s are. Then 1 0 gets cancelled here. Then this 3 gets cancelled here. So we are left with 10 square V1 is equal to 2 by 10. So this 10 square goes below this. We have V1 as 2 into 10 to the power minus 3 meters per second. So the answer is 2. X is 2. This X is 2. Okay. That's all, students, in this video. Thank you for watching my channel.